Welcome back, folks. So in this video, we're going to talk about how to shift graphs. And I think a way to show this, and there are several ways to show this, but the way I'm going to show it is through example. So we're going to start off with our parent function of just f of x is x squared. And so I drew that on the left here. So that's the black one. Nothing too tricky here. Negative 2 squared is 4, and so is positive 2 squared is 4. And I just drew our function from negative 2 to 4. Sorry, negative 2 to positive 2. What I want to do then is I'm going to take that parabola and I'm just going to drag it upward 1 unit. And so what I did, and that's what the red graph is here. So the red graph, we're going to just call that one g of x. All right, this graph is g of x, whereas the black one is f of x here. Okay, so the question is, what is the equation of g of x? And the way we can see this is if we just think about how every point on the black graph has a corresponding point on the red graph. And we're going to do this again with horizontal shifts as well. And so all these green points that I'm highlighting, well, maybe I'll do it in different colors, but this negative 2, 4, when I dragged it up, that became now negative 2, 5. And I'll do just one more here in blue. The point over here, 1, 1 on the black graph became 1, 2 on the red graph. And so we can see here that what stays the same between the two graphs? Well, we can see that the x value still stays the same, right? But their y value doesn't. And so I can think of this, if this point right here is negative 2 comma f of negative 2, right? Because I input negative 2, then this one over here on the red graph, g of x, that'd be simply negative 2 f of negative 2, or sorry, f of negative 2, g of negative 2. But the question is, how can I relate, because that's what we're trying to do, is use what we know about the parent function to come up with the equation of the now transformed graph. If I rewrite g of negative 2 as, well, it's the exact same point, f of negative 2, just what happened to it? It's just 1 more than what it was. 4 plus 1 is equal to 5. So I could be, it's just 4 plus 1, or I can think of it as f of negative 2, and then you add 1, 2 on top of it. Likewise, we could think of it down here on the blue one. This graph, or this point, is 1 comma f of 1. Over here, this point is 1, g of 1, of course. But that g of 1 is, instead of writing it as 2, I'll do 1 plus 1. Or that first one right here, this is really just the original f of 1 bumped up 1 in the y direction, up 1. That's why this is like the original y plus 1. And so all we need to do is, in order to shift the graph upward, and likewise downward, you just add some constant to it. So really, g of x here is this exact same thing as f of x, just bumped up by some amount, however much you want. If you want to bring it up 1, you're just going to add 1 to all the y values, plus c. Or if you want to drag it down, then that, I'll still say it plus c, but if you're going to drag it down, then that c would be a negative y value, or it would be a negative number. So for example, if I wanted to graph, I'll slide over here, example, if we wanted to graph, let's say f of x equals absolute value of x minus 4, pretend. That's not too bad. I'll start off with my parent function here. So I'll draw the parent here in black again. Oops. Y equals absolute value of x. And we know that looks something like this, like a V shape with a slope of 1 or negative 1 on the left side. Then all you're doing is taking the exact same y values, just pulling them down 4. And so this will go 1, 2, 3, 4. And now the vertex of that absolute value graph is just going to be down here now. Oops. Let's show that a little bit better. And there you go. And that is what that graph would look like. So now that we've talked about vertical shifts, let's talk about horizontal shifts. And in this example, we're still going to stick with the same parent function, x squared. And so what I want to do in this case is I just took that same parabola and now pushed it over to the right 2 units. And so here that transformed graph is my red graph right here. And so I did a similar thing here where I highlighted the corresponding green and blue points here as 2 examples. So that what happens here is that their y values actually stay exactly the same, but their x values differ because you're going left to right. So this point -2, 4 becomes now 0, 4. And the blue one, 1, 1, becomes now 3, 1. And so their y values are the same. So I do know that this point right here, and again I'm going to label it, this point on the green point on the black graph is -2, comma f of -2. And over here on the red one, I know that this point is 0, g of 0. Okay, but now again, the question is how can I relate the original parent function to the new transformed one? So let's write it this way. Well, since they have the same y value, I can actually say that f of -2 is equal to g of 0. Right? Because again, they're the same y value. They're both 4 in this case. If I do a similar thing on the blue dot over here, I have 1, comma, f of 1. And then over here, I have 3, comma, f of 3. Okay, but notice again that they have the same y value, or same output, and so I'll bring it down here a little bit. I know that, that should be g. I know that f of 1 is equal to g of 3. Notice what's happening here. Observe the difference between their inputs, in that the input for g is always 2 more than the input for x, or sorry, for the input for f. Another way to think about this, is that you in a sense have to trick the function. So that's one way that I think about it, is that when you're transforming a function, you're tricking the original function. Here's what I mean. Plugging in, I'll write this out, plugging x equals 0 into the new function g, into g of x, is the same as plugging, what x value corresponds to this point from the original function was -2. It's the same as plugging x equals -2 into the original f of x. And so one way we could write that, and bear with me here, it's going to look a little confusing at first, is that I could write g of 0 the same thing as, what if I had taken 0 into the original function, f? Come on. F of 0, but again, when I plug in when I plug 0 into this, it needs to think that it's actually plugging in -2, and the way I can adjust for that is by throwing in that -2 here. So that this -2, that I'm going to highlight in, put in a rainbow box, or underline, that -2 corresponds to this shifting it over of 2. And we could notice that again on the blue point down here, in that g of 3 is the same thing as f of 3 minus 2, because again, when I plug in 3, I had to make the original function think it's only plugging in 1, because that's where the corresponding point came from. And so this, again, -2, comes from that shifting it over 2 units. And so really, what's actually happening here, and this one is kind of hard to explain, so I apologize if that didn't quite work out. I'll try to figure out that, try to get another explanation for you. But really, g of x is simply equal to, well, let's actually do this example, f of x minus 2. And it's really important where the parentheses go, because if I just did f of x, take away 2, then that'd just be a vertical shift pulling it downward. Remember, now you're replacing the input with x minus 2. And so this graph, well, if this actual example would be x minus 2 quantity squared. And so the idea here is that if I plug in an x value into the new function g, it really is just the original function, just thinking that it's 2 units backwards. And so that result ends up being brought forward, more forward being to the right. And so the idea here, if you want to push a graph c units in the right in the positive direction to the right, you're just going to replace f of x with f of x minus c. Quick example of this, if I actually graphed one, so let's go back to the absolute value one. I want to graph in red here f of x. Sorry, let's graph f of x is equal to the absolute value of x plus 3. Then if I'm thinking of it in terms of horizontal shifting and what is my c, this would be f of x, absolute value of x minus negative 3. Because now this says shift the original parent function, square root of, absolute value of x, to the right. Always think of it as to the right, negative 3 units. Now, negative 3 units to the right actually just means 3 units to the left, remember? And so I'll draw here my graph. So if here's my parent function, my parent is absolute value of x. That's going to look something like this. Then my resulting transformed equation is just going to be right here at starting off at negative 3, or my vertex is at negative 3. So hopefully that video wasn't too confusing. Again, the way my brain works is it thinks transforming the function, at least horizontally, shifting horizontally, is just tricking the function into thinking you're ahead or behind of where the original function was. Take a look at this, try some practice problems, and then let me know if there's any questions. Alrighty? See you in the next video, in which we will talk about compressions and stretches.